for an innovative and a case study question that we are going to discuss. And finally, we'll finalize so which are the case study and innovative questions which you can take. And here only I will show you the material and all, how you can go through that and all. Now I will share this screen, whatever is there, and we'll go with that particular thing. Just share the entire screen. Right now, I'll start with select share. Right. You can hear me, right? Are you? I'm audible to you?
Yes, sir.
Yeah, I'm audible. I'm audible, right? Now, yeah, back here, and just we'll go with an some real-time applications here. Just I'll go with Google now, and you can see now some real-time applications of BFS and BFS. So BFS applications of. Hello, who is that speaking? Hello, who is that speaking? Any problem? Any problem?
So some of them couldn't able to join the.
You mute everyone. ನಾನು ಈ ಫಾರ್ಮ್ಯಾಟ್ ಫಾಲೋ ಮಾಡಲ್ಲ. ನನಗೆ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಕನ್ಕ್ಲೂಷನ್ ಇಲ್ಲ ಅಂದ್ರೆ ಇಟ್ಸ್ ನಾಟ್ ಕರೆಕ್ಟ್ ಆಫ್ ಎ ಸಿನಾಪ್ಸಿಸ್. ನಾನು ಹೇಳ್ತೀನಿ ನಾನು ಸರ್ ನಾನು ಹಾಕೊಳ್ದೆ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಅಂಡ್ ಕನ್ಕ್ಲೂಷನ್ ಇಲ್ದಿರ ಸಿನಾಪ್ಸಿಸ್ ಆಗಲ್ಲ. ಕನ್ಕ್ಲೂಷನ್ ಇಸ್ ವೆರಿ ಮಚ್ right. Back here, right? What's the problem? Right, now I'll go with the things. Now we'll see here the real-time applications of BFS and BFS first we'll see, and later on we'll see how this will be used in different platforms and all, whether it will be suitable for innovative and all. It's used to in different places. That we know how to. It's not so worth like you. No way, we are not getting so much on this. Real-time application of which see here, open shortest path first. It will be implemented in that, and both in a link state routing protocol, IP routing to find a open shortest path first. So there it has been used. Why can't we take this as a case study question that I'm thinking on that? Social networking, shortest path, digital mapping services in Google Maps. Many times we have tried to find the distance in Gmaps from one city to another, or from your location to the nearest desired location. there encounters the shortest path as there are various routes, paths connecting them, but it has to show the minimum distance. So distress algorithm is used to find the minimum distance between two locations along the path. Consider India has a graph and represent a city places with the vertex and the route between two cities can edge. Then be using this algorithm, the shortest routes between any two cities or one city or another city can be calculated. How is this? Come on. How is this? Hey, you're not interacting with me. What's the problem?
Nothing, sure, we got it.
Sir.
Now, what? How is this problem?
The
How is the
problem for case study.
problem? It's good, right?
Yes, sir.
Yes, sir.
We can take this for a case study question. Otherwise, what else if I click over here? Just I'll show that also. Just it will be algorithm will be there. That's it. Shortest matrix representation, list representation. So algorithm is there. That's it. Nothing. So this is good enough to take that. Otherwise, if we go with open shortest path first algorithm, let us see how distress algorithm will be used there. Router ID is the highest activity IP address, router priority, destination router, backup. Honest states, long, initiate. Oh,
Sir,
ah,
sir, otherwise you can take Prims and Krishkal's comparison as real time examples for case
No,
study.
this is good. No, I think ನನಗೆ ಏನು ಅನ್ನಿಸ್ತಾ ಇದೆ ಇದು ತುಂಬಾ ಚೆನ್ನಾಗಿದೆ ಅನ್ನಿಸ್ತಾ ಇದೆ. ಯಾವುದೋ ಒಂದು ಮ್ಯಾಪ್ ಕೊಟ್ಬಿಟ್ಟು ನಿಮಗೆ ಯಾವ್ದಾದ್ರು ಒಂದು ಮ್ಯಾಪ್ ಕೊಟ್ಬಿಟ್ಟು ನಾನು ಒಂದು
Sir.
ಕರ್ನಾಟಕ ಮ್ಯಾಪ್ ಯಾವ್ದಾದ್ರು ಒಂದು ಕೊಟ್ಬಿಟ್ಟು ನಿಮ್ಗೆ ಡಿಫ್ರೆಂಟ್ ಸಿಟೀಸ್ ಇರೋದು ಕೊಟ್ಬಿಟ್ಟು ವಿತ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ನಾನೇ ಡಿಸ್ಟೆನ್ಸ್ ಹಾಕಿ ಕೊಟ್ಬಿಟ್ರೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಶಾರ್ಟೆಸ್ಟ್ ಪಾಸ್ ಮಾಡೋದು ಈಸಿ ಅನ್ಸುತ್ತೆ. ಏನಂತೀರಾ? I thought this is
Sir.
one of the means ಒಂಥರ ಹೊಸ ತರ ಇರುತ್ತೆ.
Yes,
Am I
sir.
right?
Yes,
Huh?
sir.
Correct ಅಲ್ವಾ?
Yes,
sir.
sir.
Okay. Related me. So this is a one case study question. Okay, fix it. If you want, you can make a note of this where it is there and all. Just what I will do, I will give you a graph of Karnataka state or something like that. Within the cities I will give and I will mention you the distances within that. From there, you have to calculate the shortest path from the source to the destination. Got it?
Yes.
Got it?
Yes, sir.
Right. So this is case study is over then. And now come back to the innovative questions. So innovative questions, then what we can go with this one I think means trims and crystals. So innovative concepts. Comparative applications of trims and crystal algorithm. So innovative, they are not taking into the consideration there. Extreme algorithms. Do you use a Google search? Do you use a Google Maps? Do you use social media sites? Yes. If as to any of these questions, then you have I definitely used graphs and you didn't even know it. Surprised. I was to data structures really caught my attention with the amazing capabilities and diverse real world applications. Can also use media algorithm use another. Always keep a connected component starting. Applications where critical algorithm is generally used. Landing cables, TV network, tour operations, LAN networks, network of pipes for drinking water or natural gases. So what is a good applications, man? An electric grid, signal like cluster applications where Prim's algorithm is generally used. All the applications stated in critical it has been used. Network for roads and rail tracks connecting all the cities, irrigation channels and placing microwave towers, designing a fiber optic grid, or I say traveling salesman problem. This is important. Cluster analysis, pathfinding algorithms used in AI, game development, cognitive science. Wow. How beautiful, right? Myself, I'm saying the first time. So these many applications is there of Prims and Criscal, and even so many applications it has been used. Okay, take it as an innovative question, and elaborate it, and you have to write more. And that is very much important here. Not only what is there here, or not only this much, and you have to take elaborative on this particular thing, and you have to write. Okay, okay.
Okay, sir.
Others.
So,
Yes,
so only
sir.
shortest drop and this Prim's algorithm too, no, sir.
Prims and Criscals will be there for an innovative, and distros will be there for this one, means case study question.
Yes, sir.
Okay, okay, sir.
Okay, okay.
Okay, sir. Yes,
Yes,
sir.
sir.
Now come back to this one, means your syllabus. Now, any doubt is there? Any of the things you having a doubt? That concept, I will redo it, and once again I will tell you. Any concepts is like that, which is you are having a doubt?
So quick sort.
Huh?
Sir,
Quick sort.
physics.
Quicksort, right. Now, Quicksort, I will write the textbook format you have seen, but I will do now Quicksort like in a general way how we are going to do the Quicksort, and then you can see how it will work, right? Now I will share the ice cream. Just a moment. 1 minute. I'll share now. Yeah, now we'll start with. ಅಪ್ಪಾ ಇದು ಮತ್ತೆ ಸ್ಟಾರ್ಟ್ ಆಯ್ತು. 1 minute, huh? Yeah, quick start. Now, coming to the first, I will write an algorithm, right? So we'll start with an algorithm that is quick start, void, you can give, let we'll see. quick sort. What we need actually here, you need an array that is int of a you need, and then you need the L, and you need H. Let it be. We'll see whether that is void or not. Later on, we'll see. Don't worry about that. Now, if L is less than H, what you are going to do? First, you are going to find the means partition or a pivot element. That is important. Just I will give it as a P. P is equal to partition. What you have to send here? You have to send A, and you have to send L, and you have to send H. So then again, what you have to do? You call quicksort again. Quicksort again. You should call with A. L will be there here, but here P minus 1. So then again, quicksort you should call. That is A will be there, here P plus 1 will be there, and H will be there. Now close this, In this way, just a minute. Yeah, so this is one algorithm. The second algorithm I will go int partition. For you, I think all confusions will go now. Int A, and I will take int L and int H. Now I'll start here. What I will going to do? Let low is equal to L, and high is equal to H, and pivot element I will take. Let it be P is equal to A of L. What else you want? That's it. Next, while one start. What you have to start? Right. Yeah, while one. Consider the pivot element. How you are going to consider? While A of I, whatever is there, if it is 1 minute, if it is less than I think, it is less than the pivot element, less than or equal to the pivot element, and I should be less than 1 minute. Just 1 minute. Yeah, I is less than J. Then what you have to do? I plus plus. Then while A of J is greater than or equal to P. I am doubting this, either greater than or equal to, either greater than or equal to or less than or equal to, we'll decide it later while tracing, don't worry about that. J minus minus. Then after this, after doing this, what you have to do? You have to go with a condition. That is, if I is less than J,
So the greater than or equals to J ಬರ್ಬೇಕು.
greater than J na.
Greater than or equals to J if condition.
ಅಲ್ಲ ಕಣ, ಲೆಸ್ ದ್ಯಾನ್ ಜೆ ಮಾಡೋಣ ಫಸ್ಟ್ ಇರೋ. ಐ ಇಸ್ ಲೆಸ್ ದ್ಯಾನ್ ಜೆ ಏನಾಗುತ್ತೆ? ಸ್ವಾಪ್ ಎ ಆಫ್ ಐ ವಿತ್ ಎ ಆಫ್ ಜೆ. ಅದೆಲ್ಲ ಮಾಡಿದಾದ್ಮೇಲೆ ಎಲ್ಸ್ ಒಂದು ನಿಮಿಷ. Right. Now I'll start here. Else. Else ಏನ್ ಮಾಡ್ಬೇಕು? ಹೇಳಪ್ಪ. ನಾನು ಮಾಡ್ಕೊಡ್ತೀನಿ. ಫಸ್ಟ್ ಬರೆಯೋಣ. Swap A of low with A of J. Then return J. Close the while loop, main while loop. That while loop will be there, that you have to close, and you have to close this. Almost all we did, right? Now we'll go with the tracing, then you can understand easily what we did and all, right? Now you take the elements 7, 5, 1, 2, 4. Right. Now, what the first thing we have did, L and H. Now assume L and H you have to make like this only, and you have to call the quicksort function. Now L is less than H. I will write the indexes here: 0, 1, 2, 3, and 4. 0 is less than 4, condition is true. Now P is equal to partition of A, L, H you are taking. Now come to the partition function. Now in a partition function, observe carefully, I am making a low here, am I right? And then high, whatever is there, I will take here. Instead of 1 minute, just low L, I will go to back, I'll go to back, just a minute. Now here, you see the mistake here. Yeah, what is the mistake here? Low is equal to I, it's okay, but I is equal to H. Instead of that, you take J. J is equal to H, and I is equal to L plus 1. That you keep in your minds. That two things I have left it. You take it. That is low is equal to L, and I is equal to L plus 1, and I is equal to H. Now next we'll move.
Excuse me, sir. Sir, the previous which we have did, sir, we have taken I equal to L and J equal to R.
R plus 1, that is we have used repeat there, repeat until we have used. That means first we will get into the instructions and later on condition, but here we are using while. That is first condition, if condition is true, then only we will get inside.
Okay, sir.
Are you getting the difference? Why I have taken this means this is a usual program which you are going to write. I thought that repeat and until it's made you confusion. You can follow this also, not a problem. Both are correct.
Okay, sir.
Yeah. Now, 7. Now, according to the algorithm, what is there here? I and J I will fix. Now, I will be there at L plus 1 and J will be there at here. Now, I think everything we have taken, and this is a pivot element. Entire 7 will be your first pivot element. Now, while true, always it will be true. That you have to keep in your mind. While 1. So get inside. While A of I is less than or equal to the pivot element, that is 5 is less than or equal to 7. Are you getting? 5 is less than or equal to 7. Loudly.
True.
True, sir.
True means what happens? I will shift. Observe carefully. 7, 5, 1, 2, 4, and I will be there here at 2. Next, what happens? 1. 1 is less than or equal to 7. Loudly. True. True means again I will increment. That is I will be here. Next, 2 is less than or equal to 7. First condition itself it is true, and I is less than J. I is less than or equal to J. Condition is true. True. So then you can take that. Now both the conditions are true. What happens? 2 is less than 7. I will increment. That is 5, 1, 2, 4. Now again I will be here. Observe carefully. I will be here. Now again you are going to check. Again, you are going to check. Now observe carefully. 4, whatever is there here, and j is also here. 4 is less than or equal to j. True. Condition is true. 4 is less than or equal to 7. Condition is true. And what is the I value? I value is also 4, and j value is also 4. Index 4. 4 is less than or equal to 4. Condition is true. Now again I plus plus. I will come this side 1 before. Assume this is a 5th index. Just for a sake, I will tell you now. Got it? Again, loop repeats. This is important. Again, loop repeats. The first condition here is no values is there, and second condition I is less than or equal to j. This will also become false. Now we will come out of the loop. See the next while loop. What is the next while loop? If a of j is greater than or equal to pivot element, that is 4 is greater than or equal to 7. 4 is not greater than or equal to 7. You don't decrement the j. Now come back. Now you check, observe carefully. Now I is not here, I is this side. I is less than j, false. False means you will go to the else condition. In else condition, what is there? Swap a of lowth element, not I here. A of low element, sorry, a of low element with jth element. That is, whatever a low element means 7, you are going to swap with 4. Now 4 will come over here. Observe 4, 5, 1, 2 and 7. J is still here. Now you are going to tell return J. Return J means 4 you are going to get there, where here to the main statement, that is P is equal to 4 position you will bring. That is, now again you will call a quick sort with this part, that is 4, 5, 1, 2, 0, 1, 2, 3. Right. 4 minus
Yes,
1 is 3 only.
Yes, sir.
Now again,
Yes,
what
sir.
you have to do, now this side nothing will be there. First recursively this will be left side will be processed, then it will goes to the right side. Now what you have to do, now again partition will be called. Before calling partition, 0 is less than 3, condition is true. Now call partition. If you call a partition function, then here automatically 4 will become the pivot element, low will be here, L will be here, and I will become this, J will become this. Now again observe carefully here, some change will be there. Now what happens? You will start. Now you will start with 5. Now you will enter to the while loop, you will start. While a of I, what is the a of I? 5. 5 is less than or equal to 4? Loudly. 5 is less than or equal to 4?
False.
False. False means it never enters to the while loop, it will goes to the next. Now observe carefully, a of j, that is a of 2 is greater than or equal to pivot element 4. 2 is greater than or equal to 4?
False.
Loudly. 2
False.
is greater than or equal to 4? False.
False.
False. Correct. False means what happens? You will come to the next statement. That is, if a of I is less than j, true means 1 is less than 3. Condition is true. Now you are going to swap I and j. That is 4, 2, 1, 5. Sorry, again loop repeats. Loop repeats here, and you are going to come to the position. Now I is this, and j will be here. Now observe carefully what is happening. Low is here. Now again you are coming to the while loop. You will check 2 is less than or equal to 4. 2 is less than or equal to 4. Loudly.
True, sir.
2 is less than or equal to 4.
True, sir.
True. Next condition. I is less than or equal to j. True. Both are true. Now what happens? 4, 2, 1, I. Now I will be here. Am I right? Am I right?
Yes, sir. Yes, sir.
Yes, sir. Now again, what happens? 1 is less than or equal to 4. Condition is true. 1 is less than or equal to j. Condition is true. Then what happens? 4, 2, 1, 5. I and j. Now observe carefully. J. Now again loop repeats. A of I. 5. 5 is less than or equal to 4. 5 is less than or equal to 4.
False.
True, sir.
False. False means you will leave the I while loop, you will come to J while loop. Now observe here, A of J, 5 is greater than or equal to 4. 5 is
True,
greater
sir.
than or equal to 4.
True.
True. True means what happens? J will be decremented. That is 4 to 1. J will come here and I will be here only. Right. Now next loop repeats. 1. 1 is greater than or equal to 4. Loudly. 1 is greater than or
False.
equal to 4. False. False means you will come to the next statement. Now observe carefully. If I is less than j, no, I is this side, j is this side. I is not less than j. Go to the else part. Else part, swap a of low with a of j. That is 1, 2, 4, 5. Now you will swap like this. Now this is J. Now you tell return back J. J position is 2. You will return back 2. Next array will be 1 and 2. 1 and 2 will be the next array. In that next array, you are going to fix L and H. That is, L is 0 is less than 1. Condition is true. Again, get inside. Call the partition function. Now in a partition function, I will be here, J will be here, and low will be here, and 1 will be the pivot element. Now go to the next. That is A of I, 2. 2 is less than or equal to 1. False. False means come to the next statement. A of J. A of 2 is greater than or equal to 1. Condition is true. True means decrement J. J will become here. 2, I will be here only. Now again, 1 is greater than or equal to 1. This is important. Greater than or equal to 1. Greater than or equal to 1 means?
True.
Loudly.
True, sir.
True. True. Am I right?
Yes, sir.
True. So J will be decremented. Again, J will become this side. Am I right? Again, J loop repeats. Here nothing will be there in a Jth position. That is, -1 will be there. Am I right? So there no value will be
Yes,
there.
sir.
Condition will be, 1 minute. Oh, yeah, I got your doubt. Right? So here, because to solve this, we will remove this greater than or equal to. You will make only greater than P. Then you check. If it is only greater than P, what happens? J will become false and you will come out. J will be at 1th place. Am I right? Am I right?
Yes, sir.
Yes, sir.
Am I right? So what happens thing here, when you come to the next stage, you see the next stage when you come. If A of I is less than J, you will tell means no, it is wrong. Then what happens? You will go to the else part. Now you are going to swap A of low with A of J. That is 1 with 1. 1 with 1 means it will be in the same position. Am I right? Then you will return J. That means you will return 0. Observe carefully. You will return 0. 0 minus 1 is -1. There, the first quicksort will fail. Why? Because L is less than H will become false. Now automatically, this everything is sorted. That is 1, 2, 4, 5, 7. Finally, any doubt you can ask me. Any doubt?
No, sir.
Elipa? Others?
No, sir.
No, sir.
Anybody? Any doubt? I will redo again if you want. No, right? See what algorithm I have written, it's correct. Almost all it's correct. Just declaration I have missed. So after so many days also I can write an algorithm. Very simple it is. Quicksort, first what it will do, you should first check low should be less than always high. That is important. Then you have to call the partition function and fix the pivot element to P or some variable. Then afterwards, you should call the same quicksort function from low to the pivot element -1, and then you should call again pivot element +1 to the I. You should do 2 partitions there. Then you have to call that. So that is first function. Coming to the partition, you're going to fix the first low element as a low, means L as a low, and I will be always +1, means the next element, and J will be the last element. So, and pivot element will be the A of L, that you have to keep in your minds. That is first element. Now you start with while one is always true. Now first thing what you have to do, you should increment the I. When you should increment the I, if A of I value is less than or equal to the pivot element, then you have to increment. After incrementing, you should check another thing also. If I crosses J, that doesn't have a value. Because of that, I should be always less than or equal to J. That you have to keep in your mind. Then only you increment the I. Then another while loop will be there to decrement J. That you have to keep in your mind. That is how you are going to decrement. If A of jth element is greater than P, not greater than or equal to, only greater than P, then J minus. That means you are decrementing the J. Okay, after varying the I and J, you will stop at one position. Then what you have to check, if that I is less than J, you should swap ith and jth element. Else, if I is greater than J, what you have to do, you should swap low, not ith element. Keep in your mind, many will make a confusion like that. You should swap A of lowth element with jth element, and you should return the jth position. Return J will be the stopping of that particular function. If you doesn't give the return J, it never stops. So why? Because we have started with while one. That you have to keep in your mind. That will goes to the infinite loop. While a programmer, you should think in this concept. So whenever a function is there, if I have asking a return value is int, so somewhere I should return. That you should keep in your mind. So always in else part, I'm going to return J. That you have to keep in your mind. That J will come and sit in P always. So this way quicksort will work. Quicksort is very simple. That's it. Got it?
Yes,
Got
sir.
it?
Yes, sir. Yes, sir.
Yeah, just I'll stop sharing of this. I'll go to the next questions.
Can you explain Dijkstra again? Once.
Distrust algorithm. 1 minute. You want distrust algorithm, right?
Yes, sir.
15 minutes to say. I'll try. Just a minute. Yeah. Distrust algorithm. Distrust algorithm is a very simple. You can take like this. What is a distrust algorithm? Always we'll see like this. We'll take a source vertex. From that particular source vertex, you will keep on. You will take the shortest one first. From there, again you are going to check from the shortest, which is the next node, from that node adding up with all other nodes, whether it will become less than the existing distance. If it is less than the existing distance, then you are going to change via route. That concept you have to keep in your mind always. For example, I will tell you like this, again I'll share. Yeah, again I will share. Okay. So I J, right? K. Same thing. Initially, I to J, assume there is a 10. I to K, there is some 2. Just for a sake, I'll tell you. Now, I will write like this. I will take I as a source node, right? Now, from I to J, it is 10. Note down. Then I to K, it is 2. Note down. Are you getting everyone? You should mean that. Very simple. I am going to tell you. Right. Now assume, just for a sec, I'll tell you. K to J, let it be 2 again. Just for a second. Now come back. Now here from I, which is the shortest one, I to K is the shortest one. You consider that. That is I to K. It is always 2. You consider that. Now again, what you have to do from K to other element, other adjacent elements. What is the distance plus I to K? You have to check. That is from K to J, it is already 2, and here already 2 is there. 2 plus 2, 4. 4 will be compared with this J. Now, if we go direct with I to J, it is 10. 4 is less than or equal to 10. Condition is true. Less than or equal to you can put, or less than you can put. It's not a matter. So 4 is less than 10. Yes, it is true. Then instead of going direct, what I am going to do, I will change this, that I via K, J, if you go, it will become 4. Are you cleared? Cleared, everyone? Getting?
Yes, sir.
Yes. Now, which is the one thing which is left out is only one thing, that is from I to K and I to J, it will be 4. Right, now 2 shortest paths are there. I to K it is 2 and I to J it is 4. I am going to display that. Very simple. Rupak,
Yes, sir.
got it?
Yes, sir.
Then bigger graphs will be there. You take bigger graphs and keep on producing. That's it.
Okay, sir.
You want me to take big graph and explain?
So once with the same one, sir. Means the
Huh?
last time we did.
Last time we did, right?
Yes, sir.
I'll take. You have to tell the values there. That is the A we have taken like this only, right? B, am I right? C, D, E, F. Tell me the values. I have forgotten. Oh, I have not changed. Sorry. I'll rewrite. A, B. 1 minute. A, B, C, D, E, F. Yeah, you tell me now. A to B.
A to B is 2.
2,
B to D is 5.
1. B to D.
5.
5. Here.
D
C
to
to E.
So 2. C to E 2.
Ah.
D to E is 1. D to
One.
E is 1. Yes, sir. D to F is 1.
1.
E to F is 3.
3.
Yes, sir.
Correct?
Yes, sir.
Correct?
Yes, sir.
Yeah. Now, what we have to start? We have to start with A always. Start with A. Now I will do this. This is the selected vertices. Other vertices will be there, and this will be the graph. I'll write the headings, and other vertices selected vertices. Now A you have taken. Now A to B, what is the value? A to B, 2. A to C, what is the value? A to C, 3. Now A to D, what is the value? A to D, 999. A to E, what is the value? 999. A to F, what is the value? 999. This is the initial. So I have selected A. Any doubt is there? You can ask me. This is the initial distances from A to other vertices. Out of this, select the minimum one. I will select the minimum means A to B, that is 2. Now you select again from B other things, that is from B to C you select. What is B to C? It is 1. Already A to B it is 2. 2 plus 1 it is 2 plus 1 it is 3. 3 is less than 3. 3 is less than 3, false. False means I don't want, I want same value. If it is same, I don't want to change. Very clear. Next, D is there. Now A to D directly it is 999. Now from B to D it is 5. 5 means 5 plus 2, that is 7. 7 is less than 999. True, 7 is always less than 999. So via B, if you go to D, it will be 7. Make a note. Now come to E. Now B to E it is 999. So no need to change. Why? Because it will become more than the existing. That is A comma E comma 999. Now A to F, B to F it is 999. That means it will become still more. No need to change. That is B, A to F. Let it be 999 only. Now you have selected a graph A to B. Let it be 2. Now close this. This is correct. Now next, what is the next thing you want to take? I will take the next minimum thing, that is A to C. This is good. Now A to C I am going to take directly, that is 3. Oh, sorry. Now A and B is already over. We have taken C to other nodes. You have to get into the things. Now C to D 999. Now already it's 7, so I no need to go with that. That is A comma B comma D comma 7. Let it be okay for me. Now coming to E, A to E is 999, but if you go via C, it will be 2. That is A to C is 3. 3 plus 2 it is 5. 5 is less than 999. True. So if I go via C to E, it is 5. Note down this. Next. Sorry, next F. Coming to F, C to F it is infinity, 999. So it will become still greater, no need to change. That is A to F, let it be 999. Now how my graph looks? Graph looks like this. A to B 2 and A to C is 3 that I am taking. Now next, you take the minimum value again, that is A to C, C to E. Total I am taking it as a 5. So now from E you should go to the other things, whatever is there. From E, if you go to D, observe carefully. If E, if you go to D, already it is 5. 5 plus 1 it will be 6. Now 6 will be compared with existing D, that is 7. 6 is less than 7. So then replace it. That is via C, E, if you go to D, it is 6. So we replace it that. Now remaining is F. When you go to F, 5 plus 3, it is 8. 8 is always less than or equal to 999. That is A, C via E. If you go to F, it is 5 plus 3, 8. Take that. Now, how your graph will look? A, B, C, E you should take. E, 2. Let it be. Now again, what you have to do? Again, you take the next shortest. What is the next shortest? Next shortest is A to C, C to E, and E to D. That is 6. That is the shortest one. Right. Now remaining is only 1. That is F. If via D to F, if you go 6 plus 1, that will be 7. But now it is 8. 7 is less than 8. True. True means change the path. Means change the route. A, C, E, E, D, and F. If you go, it will be 7. Right. Now, how you are going to consider now graph? A, B, C, 3, and E, 2, D is there here, D, 1. Right. Now, which is the left out? Left out is only F that you have to take. Finally, if you take that this side below, there is no space, that's right. If you take below, the remaining is only one. That is A to C, C to E, D to F. If you go, that will be 7. Final graph will become like this. This is 7. Now, if A to F, it will be 7. Now, A to D, it will be 6. A to E, it will be 5. A to C, it will be 3. A to B, it will be 2. In this way, distress algorithm will work. Getting?
Yes, sir.
Huh?
Yes, sir. Yes, sir.
Okay. Now, what else? So time up, I think. Next class, we will discuss. Okay. Okay.
Yes, sir.
Yes, sir.
Yeah, I take attendance. Data structures with algorithms. Just I'll save this. Yeah. Revision 1. I will upload this iScrub also into the YouTube. If you want, you can check it. Close this. Yeah. I'll call your attendance, but ನನಗೆ ನೀವು ಒಂದು ಹೆಲ್ಪ್ ಮಾಡಬೇಕು. 27th ಯಾವ ವಾರ ಬಂದಿತ್ತು? ಲಾಸ್ಟ್ 27th ಸ್ಯಾಟರ್ಡೆ ಅಲ್ವಾ? 29th ಮಂಡೇ ಬೋರ್ಡ್ನಲ್ಲಿ 30 ತಗೊಂಡಿದ್ದೆ ಅಲ್ವಾ? ಯಾ ಫಸ್ಟ್ ಅವರ್ ಕ್ಲಾಸ್ 4th of January. One minute. 30 by 3. Next, 31 by 3. April 1st, class 1 is alwa? 1 by 4. First ಆದ್ಮೇಲೆ Friday. ನೆನ್ನೆ ತಗೊಂಡಿದ್ದ ಕ್ಲಾಸ್?
No, sir.
ನೆನ್ನೆ 2 ಅವರ್ ತಗೊಂಡಿದ್ದೆ ಅಲ್ವಾ?
ನಿನ್ನೆ ಯಾವ ಕ್ಲಾಸ್ ಇಲ್ಲ ಸರ್.
ಗುಡ್ ಫ್ರೈಡೆ.
ನೆನ್ನೆ ರಜಾ ಇವ್ರವ್ವ ಕರೆಕ್ಟ್. ಸೊ ಇವತ್ತು 3. 2 ಅವರ್ ತಗೊಂಡಿದ್ದೆ ಯಾವಾಗ ಕಣ ನಾನು? ಫಸ್ಟ್ ದಿನ ಅಲ್ಲ?
ಥರ್ಸ್ಡೇ ಸರ್.
ಹಾ 1 ನಿಮಿಷ. 2 ಅವರ್ ತಗೊಂಡಿದ್ದೆ. ಇವತ್ತು ಮತ್ತೆ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ. Am I right? 3 by 4. Now answer your attendance. Anaga?
Yes, sir.
Anaga?
Yes, sir.
Abhilash?
Yes, sir.
Akhil? Akhil? Akrut?
Yes, sir.
Akshay? ಇಲ್ಲ ಇವನು. Aravind?
Present, sir.
Arifullah?
Yes, sir.
Anusha?
Yes, sir.
Benaka?
Present, sir.
Banu Prakash?
Yes, sir.
Bhargav?
Yes, sir.
Rahmatullah?
Present, sir.
Chaitra?
Present, sir.
Chandana?
Present, sir.
Charan? ಇವನ್ ದಡ್ಡ ಆನ್ಲೈನ್ಗೂ ಅಬ್ಸೆಂಟ್ ಆದ್ರೆ ಹಿಂಗೆ ಇವನು. ದರ್ಶನ್?
Present, sir.
ದೀಕ್ಷಾ?
Present, sir.
ದಾಕ್ಷಾಯಿಣಿ?
Present, sir.
ಕಿಶನ್?
Present, sir.
ಹರ್ಷದ್? ಹರ್ಷದ್? ಇವನೊಬ್ಬ. ಹೇಮಲತಾ?
Present, sir.
ಹುಮಾ? ಜಯಂತ್?
Present, sir.
ದಿವ್ಯಾ?
Yes, sir.
ಕೌಶಿಕ್?
Present, sir.
ಲಕ್ಷ್ಮಿ?
Present, sir.
ಲಾವಣ್ಯ?
Present, sir.
ಮನೇಶ್?
Present, sir.
ಮನೋಜ್?
Yes, sir.
ಮೋಹಿತ್? ಮೋಹಿತ್? ನಾವಲ್
Yes, sir. Yes, sir.
ಮ್ಯೂಟ್ ಮಾಡೋ ಯಾರೋ reverse ಹೊಡಿತಾರೆ. ಕಾವ್ಯ
Sir,
ಸಾರಿ
it's
ನವ್ಯ
Navya.
ಸಾರಿ
Present, sir.
ನವ್ಯ ಯಾ ನಿಖಿಲ್
Present, sir.
ನಿಖಿಲ್
Present, sir.
ಇದೆಯಾ ಫಣೀಂದ್ರ
Present, sir.
ಪವನ್ 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 ಪಿಕ್ಚರ್ ಬಂತ ಇವನು ಏನ ಯುವರತ್ನಾಗ ಹೋಗಿರ್ತಾನಲ್ಲ ಏನ ಹೋಗಿರ್ತಾನೆ. ಪೂಜಾ
Present, sir.
ಪೂರ್ಣಿಮಾ ಪೂರ್ಣಿಮಾ
ಸರ್ ಪವನ್ ಪ್ರೆಸೆಂಟ್ ಅಂತ ಸರ್ ಕಾಲ್ ಮಾಡಿದ್ರು ಮೈಕ್ ಹೋಗ್ತಿಲ್ಲ ಅಂತ
ಹೌದಾ ಅವನಿದಾನೆ ಅಂತ ನನ್ಗೆ ಹೆಂಗ್ ಗೊತ್ತಾಗುತ್ತೆ?
ಏನಾಗಿದೆ
ಸರಿ ಬಿಡ. ಪೂರ್ಣಿಮಾ ಇಲ್ವಾ? ರಮಣ್
Yes, sir.
ರಶ್ಮಿ
Yes, sir.
ರೂಪಕ್
Yes, sir.
ಸಾಯಿ ಕುಮಾರ್ ಸಮೀರ್ ಶೀತಲ್ ಸಮೀರ್ ಮ್ಯೂಟೆಡ್ ಶೀತಲ್ ಪಿಕ್ಚರ್ಗೆ ಹೋಗಿದಾರ ಇವ್ರು ಗ್ಯಾರಂಟಿ ಹೋಗಿದಾರ. ಶೀತಲ್ ಎಲ್ಲಿ? ಶೀತಲ್ ಎಲ್ಲಿ?
ಗೊತ್ತಿಲ್ಲ ಸರ್, ಊರಿಗೆ ಹೋಗಿದ್ದಾಳೆ ಅನ್ಸುತ್ತೆ.
ಶದಾಬ್
Present, sir.
ಶರಣ್
Present, sir.
ಶಶಾಂಕ್
Yes, sir.
ಶಿವಾನಿ
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಸೌಮ್ಯಶ್ರೀ
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಮಾಸ್ಕ್ ಹಾಕೊಂಡು ಫೋಟೋ ತೆಗ್ಸಿದ್ಯಾ ಸೌಮ್ಯಶ್ರೀ? ವೆರಿ ಗುಡ್, ಚೆನ್ನಾಗಿದ್ಯಾ. ಸ್ಫೂರ್ತಿ
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಶ್ರೀ ವಿಷ್ಣು
Present, sir.
ಸುಗಂಧಿನಿ
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಗುಡ್. ಸುಷ್ಮಾ
ಸರ್ ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಸುಷ್ಮಿತಾ ಬಿ ಎಸ್
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಸುಷ್ಮಿತಾ ಯು ಯಾಕೆ ಅಬ್ಸೆಂಟ್? ಊರಿಗೆ ಹೋಗ್ಬೇಡಿ ಅಂತ ಹೇಳಿದೀವಿ, ಊರಿಗೆ ಹೋಗ್ತೀರಾ. ತೀರ್ಥ
Present, sir.
ತೃಪ್ತಿ
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ವರ್ಷ
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ವೀಣಾ ಸಂತೋಷ್
Present, sir.
See, one thing Ganesh sir has told me that you can do that at CN lab. That is, before what you did NS2 and all, ನೀವು ಏನ್ ಮಾಡಿದೀರಾ, just now Maki you did like that. I will take some theory classes of TCL scripting. What is TCL script? How TCL script coding you should do, and how general programs you can do using TCL scripting. That I will teach you. Then you will get an idea how the real NS2 TCL scripting you can do. If you wish, I will do. Means Ganesh sir told me that can you do like that? I told okay sir, if really student wants that, I will do. Why? Because it has been postponed. No, still April 30. Time is there that we can cope up with the NS2 lab programs. That is my both HOD sir and mine idea. What about you? What is your opinion?
Yes, sir.
Yes, sir. You can do, sir.
Yes, sir.
ಸರ್
It will be very helpful.
ಬೇಕು ಸರ್ ಅದು
Yeah, ಬೇಕಲ್ವಾ? So what my idea is, TCL scripting ಅಂದ್ರೆ ಏನು? First tool command language ಅಂದ್ರೆ ಏನು? Unix ಅಲ್ಲಿ ಅದರ ರೋಲ್ ಏನಿದೆ? Why it is not dependent on NS2? Can we do our own programs using TCL scripting? ಅವೆಲ್ಲ ನಾನು ನಿಮ್ಗೆ ಹೇಳ್ಕೊಡ್ತೀನಿ ಫಸ್ಟ್. ಅದಾದ್ಮೇಲೆ TCL ಸ್ಕ್ರಿಪ್ಟಿಂಗ್ ಇಂದ ಯಾವ ರೀತಿ ನಾವು C ಪ್ರೋಗ್ರಾಮ್ಗೆ C++ ಪ್ರೋಗ್ರಾಮ್ಗೆ ಲಿಂಕ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳ್ಕೊಡ್ತೀನಿ. ಅದಾದ್ಮೇಲೆ ನಿಮ್ಗೆ NS2 ಈಸಿಯಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ. ಸೊ ಐ ನೀಡ್ ಸಮ್ 3 days ಸೆಷನ್. ಇವಾಗ CN ನಲ್ಲಿ ಏನಾದ್ರು ಡೌಟ್ಸ್ ಇದ್ರೆ ಕೇಳಿ. CN ಮಾಡ್ಬೇಕಾದ್ರೆ ಆಲ್ಟರ್ನೇಟಿವ್ ಆಗಿ ಒಂದಿನ ಒಂದಿನ DS ಒಂದಿನ CN ಮಾಡ್ತೀನಿ. DS ಅಲ್ಲಿ ಏನಾದ್ರು ಇವತ್ತು DS ಮಾಡಿದ್ದೀನಲ್ವಾ, ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಏನ್ ಮಾಡ್ತೀನಿ ಆನ್ ಟ್ಯೂಸ್ಡೇ. ಐ ವಿಲ್ ಡೂ ಟ್ಯೂಸ್ಡೇ ಆರ್ ವೆಡ್ನೆಸ್ಡೇ. ಐ ವಿಲ್ ಡೂ ಎನಿವೇ, ಐ ವಿಲ್ ಟೆಲ್ ಯು ದಟ್. Tuesday I will do TCL scripting. ಹಂಗ್ ಮಾಡುವ, alternate.
Yes sir, but online class offline class ಇರುತ್ತೆ ಸರ್.
ಆಫ್ಲೈನ್ ಇರುತ್ತೆ ಮಂಡೇ ಇಂದ.
So from Monday
ಆಫ್ಲೈನ್ ಇದ್ರೇನೆ ಚೆನ್ನಾಗಿ ಅರ್ಥ ಆಗುತ್ತೆ ನಿಮ್ಗೆ. TCL scripting ನಾನು ಮಾಡ್ಕೊಡ್ತೀನಿ ಬಿಡಿ, ಡೋಂಟ್ ವರಿ. And each of the programs I will tell you the highlight and I will tell you how to solve and all. You can do your own, you can write your own TCL scripting. I will make you like that. Don't worry.
Sir, from Monday we have online or offline?
Offline ma, offline. From Monday
okay.
Offline.
Okay sir.
It's very clear, only for 1 week it is online. Even our Chief Minister Yediyurappa told directly that no online classes, only offline classes will be there. Okay na?
Okay sir.
Okay sir.
Okay, then our timetable will do alternatively. 1 day DS, 1 day CN, TCL scripting. Okay?
Okay sir.
Okay, sir.
Okay, thank you very much. First I will remove the recording, then stop recording. Right.